and Ankleshwar is 75 kilometers away from my place, but still we are suffering by this pollution. I am working in the Ahmedabad, that is also surrounded by the industries, mostly the pharmaceutical industries. So it is required to decrease pollution, and when we are the organic or chemistry, being a chemistry students, our source must be the 12 principle. Wherever you work, whether you are in the laboratory or any of the industry, but your source should be that. Because like in pesticides, in agrochemicals, we are second in the world, and we are feeling proud of that. We are fifth in the dyes industry. We are fifth in the petrochemicals, some of the petrochemicals, and India is feeling proud. But other side is what we are suffering from the pollution in that context. Of course, we are doing better, but still it is lagging behind. So once you will see the 12th principle of the green chemistry. So main intention is to reduce or eliminate the pollution, and second is that if it is not there, then develop the technology that should be the green technology. So these two aspects should be remembered. So dear participants, these are the 12 principles of the green chemistry. So once you entered in the college and your subject is chemistry, then your source must be this 12 principle. When you are working in the laboratory, you can recall this 12 principle, because 80 to 90% pollution is created by using the solvents, and that is the highest contribution of the solvents to generate the pollution. So I am not giving all the names of the green principles, but the 12 principles are there. You can I can give you the 30 seconds, you can go through that, so that it can be at your heart. When you are working in the laboratory, try to avoid using the solvents, and if you wanted to use, you can use the safer solvent or green solvents, or you can try to find out the alternatives of it. So here are some of the synthesis that is given based on the organic green chemistry. So this is the simple one where acetanilide is prepared. Okay, acetanilide is prepared by using the acetic anhydride and the chlorinated solvent. So this is the conventional method, but that can be prepared in green way by using the Zn dust and the acetic acid. So here even if you can use the acetic anhydride, 1 mole of acetic acid can be unused during the process, where here that can be utilized. And this is the safer synthesis to develop the acetanilide. And in PG or UG, students are preparing this compound. Also, this acetic anhydride is the banned product because it is utilized in the narcotics also, and also in the preparation of the one of the things is very famous. I remember that, but it is there. Brown. Yes. So that is why it is banned in some of the states and that. So that is why try to avoid. So this is the alternative. This is the alternative of that. The another one is the dimethyl acetone. Okay. So in that also NaOH is utilized. Okay, so the alternative of that is, in place of the NaOH, we can have the LiOH, and that is the green concept we can say, and we can be green synthesis by using the water as a solvent, because in the previous method ethanol is utilized. The another one is the bromination. So normally bromination can be carried out by using the Br2 water, but there is an alternative for it, and this is the green by using the HBr in presence of the H2O2. So that is also green synthesis to develop the dibromo derivative of the steel beam. Here it is the another derivative, that is Alexander. Alexander reaction, organic reaction, very famous reaction, where benzene is utilized as a solvent, but same compound can be synthesized by using the water as a solvent at the room temperature. The another one is the benzylic acid, benzylic rearrangement reaction, in which 50% KOH and ethanol is utilized as a solvent, but again it can be it can have the alternative by using the KOH and the HCl. So another one is the by using the benzoin, like benzoin condensation that you are studying. Okay, so reported method is that by using the sodium cyanide, that is very toxic. But in the green synthesis, you can have the thiamine hydrochloride can be utilized to synthesize the benzene in the same benzoin in the same way. Another one is the para-bromoacetyl lime, where the Br2 water is utilized in the presence of the glacial acetic acid, but there is a alternative in which ferric ammonium nitrate in presence of the KBr can be utilized, and that is the more safer. It is not completely that we are avoiding, but we are reducing the effect of it. Here is the one more reaction, that is the adipic acid, synthesis of the adipic acid. So this is the conventional method where concentrate nitric acid is utilized, but same can be having the another route by using the H2O2 and KHSO4. Less hazardous reagents can be utilized from the to prepare the adipic acid from the cyclohexane. This is the ibuprofen, synthesis of the ibuprofen, and this is the conventional method. And this one is the green method. Okay, but what is the difference in it? So here, atom economy of this method, conventional method, is only 40%, whereas for the green method, atom economy is the 77%. So yield is increased, and most of the reagents are converted into product. Not only that, but to produce the 2 bottles of the ibuprofen, 3 bottles of the base is generated by the conventional method, whereas in the green, 3 bottles of ibuprofen can be generated, and hardly less than 1 bottle of the hazardous or waste can be generated. So this is more safer. It is not completely safer, but it is more safer comparison to the conventional method. So these are the some example I had thrown on you to get into that direction, so that we can save our earth. So now we can have the different methods to prepare, to use the principle of the green chemistry. So here is the list of the sum of the methods, and that methods can be applicable to prepare in the green route. So one of the method is this physical and chemical methods. Second one, if you look at, that is the biological methods to synthesize the compound. Third one, you can say green synthesis of the organic compounds by using the different catalysts and nanoparticles. Then metal salts, complexes and ammoids. Then the metal nanoparticles, non-metal elemental nanoparticles, metal and non-metal oxide nanoparticles, then the nanoparticles of other chemical compounds other than the metals, materials, nanomaterials, composites and hybrids, and last one is the organic synthesis by using the softwares, different softwares. So this is the heart for the synthesis, for the green synthesis. So your source must be from out of this 10. It is a very, very broad methods, by the way. You can touch only one or two, something. So sir was your HOD sir was discussing, and of course the vice principal also, that you are having the project in the MSc semester 4. So you can adopt this and you can save the environment. You can pick up one. So many reactions are available. Just you can get into that. You can pick up one of the aspect and you can proceed in your project. And of course, if you stop yourself, faculties are available around you. Okay, and you can activate your faculties also. They are activated, by the way. Okay, they are not deactivated, but they are there to support you. So you are contributing in the knowledge of the faculty, because it is very small thing that can be, it gives the direction and insight can be produced by that. So this is the source of the green methods. So in the physical and chemical method, like these are the physical methods, that bond milling, microwave irradiation, photocatalysis, solvents catalysis in green processes, hydrosodothermal synthesis, magnetic field assisted synthesis, ultrasound assisted synthesis. All these are the physical methods, and that can be treated as the green synthesis methods, where we are not using any of the chemical method, or limited solvents are utilized, or sometimes it is very solvent free also. So this is the one of the reaction, that is the Nawanger condensation reaction. In MSc or BSc practical also you are familiar with that. So this is the aldehyde, and in which you are using the amine. Amine you are using in the conventional method, but that can be possible at the room temperature by using the water as a solvent. So the amine, this amine can be replaced by the water in the green synthesis. So that is also reported by one of the scientists in the 2017, and he has adapted, and prior to that also other synthesis methods are reported by using that. Even I have also utilized the same green method by using the by preparing the Komari by using the Nawanger condensation reaction, where water is utilized as a solvent. So that is the more safer route. Now another aspect is the microwave irradiation. So this is our work that we have published based on that. So that is the isofunctionalized polystyrene supported copper nanoparticles, and economically and highly efficient catalysis for the A3 and Ka2 coupling reaction under microwave irradiation. So that was reported by our research group. So in that, this is the ketone, and this is the amine and acetylene. So that is why it is said Ka2 ketone, and F stands for the amine, and another one is the acetylene. So this is the reaction reported by earlier, okay, by the conventional method. We have reported the same method by using the nanoparticles. So the original reaction has taken place around 40 hours to prepare this compound, and with the help of the radiation we have completed within the 2 hours. So the time frame is decreased. The reagents that was utilized, that was hazardous in the conventional method, we have utilized the green solvents and the nanoparticles, that is also like 0.012 milligram. Minute quantity of nanoparticles are taken to report this. So, by the way, so many reactions are established. Today, we are having around 38 million compounds are established in the world. Out of that, 28 million compounds are the organic compounds synthesized. And my dear students, every day 3 new compounds are synthesized in the world. But I was surprised, and it is very sad for us that when the corona came, none of the compound was applicable to destroy that corona, and that is why we have struggled for at least 2 years out of that 38 million compounds that so far we have synthesized. And you are also contributing in that. And that is the very sad point. And that is why, like all these faculties and the scientists, we were working day and night in the laboratory during the lockdown, in the laboratory to contribute something. Somehow we are in a good position, India is in a good position. But that is the scenario of the organic chemistry. So the point is that you can take the established one and find out the safer route. So, can you click on this? So, like this is the
टेबल 4 होता
table.
खाली टेबल 4 में रहता
Hyperlink. Yes. So this is the reaction, and it was optimized because this is the procedure to optimization of the reaction. So in that way, like that is the research point of view. I am showing you that you have to optimize by taking the ketone and amine and alkyne, and in that you can have the derivative of the ketone, derivative of the amine, acetylene, and in that way you can report the yield. So in the original reaction, it was reported around 67% yield, where we have reported here 98% yield with the help of the nanoparticles. Okay. And it is also like 20 minutes. It has taken 20 minutes, that's it. So within that 2 hours, this reaction was completed. So here in this we have utilized the copper catalyst, and it is the solvent free, and microwave irradiation was taken place, where it provided only 80 degrees Celsius temperature was taken. So in that way we can say that it is the green approach. Okay. In what way it is green approach? That we have utilized the minimum quantity of the nanoparticles, it is a solvent free, and the time is also decreased from 40 to 2 hours. Actually the reaction has taken place within that 20 minutes. So in that way you can establish. Okay. Okay. Okay, so all this data was reported by us, like acetylene is there, and this is the acetylene derivative is taken because it should be studied thoroughly when we are looking at the research point of view. But the product is getting accordingly, where we have reported around 98% product in the same method. So all these are the derivatives by the way. So accordingly we will get the product. The another research paper or research work was reported in the chemistry select by our research group to prepare the propyl amine by the oxidative CC coupling reaction, because it is too difficult to have this CC coupling, but that can be possible by using that. So in that, again, it is the preparation of propylene aldehyde, amine, and the acetylene was taken. So that is why we can say it is the coupling reaction. So this could be over there. So same thing, but here we have taken the support of the graphitic carbon nitride. So that was the support is required to introduce the nanoparticles. So this is the support. In the previous case, that support was not taken. So it is the optimized and different derivatives of the aldehyde and the acetylene was taken, and accordingly the propylene amine was synthesized. Here again it was carried out in the atmospheric culture. Previous reaction we have carried out in the nitrogen chamber. Okay, so in absence of the oxygen we have taken it is the homocoupling, or so 2 moles of the terminal alkyne was taken, and here it is the CC coupling was taken place to synthesize the 1 3-meter. So in short, what is finding for this is that we have the heterogeneous catalyst. All these are methods utilized to acknowledge the work. The size of the nanoparticles were found, that is the 6 to 12 nanometer was found, and this was the quantity of the nanoparticles were taken. It is 0.0611 millimole per gram, and the atom economy was 94%, because all the atoms should convert it into the product. That is the intention. Now this is the another reaction that is reported by our group, that is the photocatalysis, based on the photocatalysis, where visible light was utilized. Okay, so synthesis and characterization of the Ag docked on the graphitic carbon nitride and the photocatalytic evaluation in visible light synthesis of the vinyl. So vinyl is the one of the compound that is utilized to prepare the various of the heterocycles and the annulation. That is the importance of the vinyl. So in this case, all these heterocycles can be generated by synthesizing of the vinyl. So that is why we have synthesized these vinyls. So in that also, by using the carbonic chloride and the terminal acetylene, and visible light was utilized for the 24 hours. Now we have simply used the 80-volt bulb to carry out this reaction. Yes, of course, the time was 24 hours, but in presence of that light, this reaction was reported, and around 96% yield is reported in this reaction and published in the Chemistry Select, where the silver nanoparticles were utilized and docked on the carbon nitride. So this was the findings, that it was characterized by the available techniques, where size was found, size of the nanoparticles, Ag nanoparticles, that was the 2 to 6 nanometers, and here this was the loading of the nanoparticle. This much was the loading of the nanoparticles, and this is the light source. The 80-volt bulb was taken, very heavily 420 nanometer lambda was there, and greater solvent, that is the utilized in this reaction. So these are the two approaches available for the synthesis of the nanoparticles, that is the top-down approach and the bottom-up approach. Okay, so from the bulk to produce the nanoparticles. So in the top-down approach, like chemical etching or laser regulation, mechanical milling or ball milling. So all these comes under the top-down approach, whereas for the bottom-up approach, chemical vapor deposition, salt gel process, laser pyrolysis, all these comes. Not only that, there is a greener synthesis available purely, based on the plant and the microorganisms. So leaves are available of the different plants to synthesize the nanoparticles. Roots are also there, flowers or fruits, and all MSc students are working by using the different leaves of different plants, and also microorganism, bacteria or fungus or algae. All these are the source to prepare the nanoparticles of different metals. This is the other communication that paper where we have worked on the using of the palladium catalyst, Bi2 3D, Bi2 3 dimension was taken. So that is also there where it is a good example of the CC coupling, where palladium nanoparticles were utilized. Here it is, by using the mild base, that is the K2CO3, and it was reported. Okay, so likewise all the details were given in the tables, which was explained earlier in the one of the reaction. By taking the different derivatives of the starting material, the according to that product is developed over there. So in which it was reported in this was the finding where up to 98% yield is reported by using this method, and the size was found around 10 to 15 nanometer. And the beauty of this reaction is what, that the nanoparticle or the catalyst that was utilized, that was the recyclable. So we have utilized the same nanoparticles as a catalyst 6 or 7 or 8 times, and the catalytic activity was slightly decreased, by the way, but that can be enough to carry out the reaction. The another paper was reported on the copper nanoparticles, but support was changed, that is the polystyrene resin was taken as a support. So in the previous case we have taken the support as a carbon nitride. So here the resin matrix was, styrene resin matrix was taken as a support to stop the nanoparticles. So in that also we have prepared the vinyl, and these are the application or probable application to prepare the different derivatives of the vinyls. So this is the common or general method to prepare the XND16 resin, and it was prepared by PhD students and MSc students in our laboratory, and same thing was the reported, that whatever steps we have reported here, this was the steps reported, and this resin was developed. Okay, and this was utilized to dope the nanoparticles, and this is the different study that was carried out, IR, and then the cell images of that to study the doped nanoparticles on the surface of the styrene. Then the chem and ACKNOWLEDGEMENT images is reported here to study the catalytic activity. XRD is also reported. Raman and EDS investigation is also reported. XPS is also reported in this. And finally, by using that catalytic assessment, that catalyst was established properly, and later that catalyst was utilized to synthesize the vinyl. And in that way, around 96% yield was reported, and this is the recyclability study of the catalyst, that is the nanoparticles. And I think 8 times we have utilized the same catalyst. It is recoverable, and it can be recovered, and then again it can be further utilized for the second set. And this study was supported that the catalyst, recyclable catalyst can be utilized, and catalytic activity can be possible, and it can be reusable. Now, the biological methods are also over there, to prepare the nanoparticles. So here it is synthesis by the bacteria that supports to prepare the nanoparticles. Then again here it is the actinomycetes is also there, fungi is also there, plants like flowers or leaves can be utilized to prepare the nanoparticles. Now this is the good example of the preparation of the polymer hybrid, magnetic polymer hybrids. Okay, so here it is a very giant molecule is prepared, but you can see that it required only 0 to 5 degrees Celsius temperature, and also water was utilized in that. So based on that, the bioplastic can be prepared by using the green methods. So one of the scientists has reported this bioplastic by using the different source, natural source like bioplastic is prepared by residual bioplastic and cauliflower. Okay, so that was utilized. So by taking the inspiration from this is the recently we have prepared in our laboratory, this bioplastic, and we are trying to convert into the preparation of the mask. So this work is done by my MSc students currently, and we have filed the patent on this. Already we have filed the patent, where this many samples, this for the big sheets we have prepared. Out of that, we are taking the biodegradability study, so that is why we have taken this many pieces. But it is a beautiful product was developed, and out of that, like this was prepared from the neem gum. Okay. So these are the good results. This is the standard one, but this was prepared by MSc students in our laboratory recently. So one of the aspects to prepare the biodegradable polymer, and that helps to save the environment. So one of my research scholars has reported how to prepare the biodegradable polymer material. So you can refer this in that all the approaches are discussed in this paper, and it is published in the ACS, where different methods we have reported in this paper. And in that, by using the chitosan, this was in the continuation of that work. This product was developed. It is under construction by the way. The another one is the biopolymer, that is the mictoarm. So here one of the mictoarm we have reported. So this is also very useful paper, where all the methods are discussed in this method, and it is also published, in which we have prepared this mictoarm, block mictoarm in our laboratory, and the investigation, rest of the investigation is carried out. Now I have talked about the nanocomposites. Now recently we have published and we have reported this nanocomposites. Now these nanocomposites we have reported by using the conventional method. But same work now we are doing the work by using the microwave irradiation, and we are getting very good yield. So initially it was reported by the conventional method, and same thing is converted in the green approach. So this is the nanocomposites, and recently last week we have published this research paper that is also on the nanocomposites. It is not green method by the way, but now we are converting in the green approach by using the microwave irradiation. So same, these are the different loadings of the graphene was taken place on the polyamide, and this was reported. And these are the study of the nanocomposites. Okay, so there FESM, XRD, DSE, and PGA studies are done. So this is the takeaway message for you for today's lecture. that what is the source? That is the 12 green principles are the source of your work till your and my end. Is it? Because whenever you are working in the laboratory, make sure that am I fulfilling any of the green principle? If it says yes, then you can proceed. If it says no, then you can try, retry. There is always you can go for the alternative of the conventional method. Then the 10 methods I have mentioned. You can take the support of that and you can proceed. Because biggest contribution is done by the organic chemistry students. Okay, that is why 38 million compounds are the organic compounds so far synthesized by the chemist. So those who are specifically in the organic branch, because lots of synthesis work can be carried out by them, so we should consider that. Avoid to use the solvent, or you can use the green solvents. So water is the universal solvents, but apart from that, you can use the less hazardous solvents. You can always think the alternative of the conventional method that is already published and established, but you can contribute in that. Then the pharmaceutical and agrochemical. This is the current scenario of the India, but India has not reported the current scenario on the removal of the pollution by using this. Is it? And in that, it is very sad that we are not able to convert all this waste in the lake. So, my message is go green and save our earth to save us. That is the only thing. Because being a chemistry student, being a chemist, we are the savior of the world. But on the same time, we are the destroying people of the earth. In both the way. Is it? So that is why you can balance it by using that. So finally, I acknowledge the principal, vice principal, convener, co-convener, coordinator and organizing team of this EMCC 2022 of this college. I also acknowledge my department, that is the School of Chemical Sciences of Gujarat University, Ahmedabad, Gujarat. I also acknowledge you people by having the patience, and you have invested 2 days for this conference to get some insights, because so many lectures are going to be delivered and already lectures were done. So you can acquire that knowledge, because you are now at the end of the formal education. After that you will get into the informal education, where this boundaries will not there. You are free, and where the faculties may not there, you may not be there in the dress also. There may be not the discipline the way they are maintained here. Is it? So that is our responsibility to carry out that work. So I acknowledge you people here. I acknowledge my family members also. Because of them, I am here today. I definitely acknowledge my research team, and they are the source of my work, because ongoingly we are working together day and night. Right now also, myself and my research scholar and MSc students are working around for 18 hours in these days. So most of the time we are in the laboratories and in the library. So these two elsewhere will prepare our future path. So all these are my students. Already these 3 have completed their PhD and they are in the pipeline. He went for the postdoc in the USA. So currently he is working in USA, and now he is going to sit in Russia, and he is going to inside prepare for the postdoc. So they are in the pipeline, and Siddhi Panchal, she is preparing all this PowerPoint presentation. So, and because of their support I can able to present our work very effectively. And Dr. Nikita Misra, she has completed her PhD and now she is appointed as assistant professor in same department. And she is the first student that she is appointed in the same department. So that is their contribution. So I should acknowledge them also. And I am proud of my university, that is the Gujarat University, oldest and biggest university in the Gujarat, where we are having 400 plus colleges and around 8 lakh students are accommodated in this university. In the Department of Chemistry, this is very old building where only MSc labs are located, and we are having the MSc lab with accommodate at a time 200 students in the one single organic chemistry lab, and 100 plus students in the inorganic chemistry and 100 plus in the analytical and physical chemistry. That is the capacity of labs. So around 60 meter long organic chemistry laboratory we have developed recently in this, and new building is developed now in our campus. That is the 7th floor building, and with the central AC. All the classrooms are converted into AC. So that facilities are available, and instrument facility is also available in our institute very soon. And I also welcome to you in Gujarat, that is the capital of the Western India, that is Gujarat. And this is very famous, that is the Saputara, because it is attached to the Maharashtra. So this is the lake and the museum and Giradon in Tank. So you are welcome to visit this. And next to Mumbai, Surat is the emerging city, and these are the attraction of the Surat. And the other city is the Sanskari Nagari, that is the Baroda city. MS University is located here, and historical buildings and are available over there. This is the North Gujarat side, that is the Patan, and this is the Patola, that is the type of sari available. But very few people are preparing that, and they are hardly preparing one sari in a year, but the cost is around 10 lakh rupees. Okay, so that is very famous Patola. This is the South Gujarat, where I think Friday sir has visited this places. That is the Rajkot, but this is the Somnath, very famous temple is over there. You have visited, yes. And this is the seashore, and nearby Una and Divi is there. So you may visit over there. And this is the again North Gujarat, that is the run of Kutch. So it is advertised by the Amitabh Bachchan, where blue sky with the white desert. It is very attractive place. And this is the tallest statue of the Sardar Patel, that is the Statue of Unity. Recently, 3 days back, we have visited over there. The Statue of Unity, 182 meter height is there. And I think Maharashtra is preparing the Shivaji Maharaj statue. I think bigger than, tallest than this statue, I think. You are also welcome to Ahmedabad, that is the first heritage city announced by the Indian government. It's the Ahmedabad, where this university is located. And these are the different locations. This is the biggest stadium in the world, Sri Narendra Modi Stadium. That is also located in the Ahmedabad. And the metro city, now metro started here, is also there. And this is the riverfront that is developed very beautiful. This is the night view of the riverfront and Kakaria Lake. Science City is recently established, and that is also very attractive place, and Amsterdam. And finally, welcome and thank you very much for this session. So I hope that I have taken 45 minutes. That was the first time to do it.
If anyone have questions, please ask me.
Dr. Musa.
Yeah, good afternoon.
On slide number 42, you have utilized the graphitic silver nanoparticles. I want to know, you have calculated catalytic efficiency,
Yes, yes. For each paper it was calculated.
but on slide number 42, you have not shown it.
No, I have not mentioned. Yeah, I have not mentioned. But because see, before publishing this paper, it is mandatory to report this.
Catalytic efficiency.
Yes, yes, yes.
And another one,
If it is reported with the same research group and the same, you may have the reference of it, but you should report that.
sir, another one doubt I have. How did you find out that catalytic efficiency chemical changes take place on that catalyst?
See, by visualize you may not get anything.